Welcome to my channel. In this video I will explain how to visualize mathematical shapes using TouchDesigner. Broadly speaking, the project is organized into the following sections: defining amplitude and frequency, creating slightly offset duplicates and converting them into pops, drawing continuous trajectories from points, rendering only the leading point, drawing lines that connect the origin to the lead point, final rendering. On this channel, I also post other tutorial videos mainly focused on TouchDesigner. I'd be glad if you subscribe to the channel. Let's get started. First, I will explain the behavior of the operator called chop to pop. Add an LFO chop and create channels named X and Y. When you select channels X and Y, those channels will correspond to the pop position components P0 and P1, respectively. Please note that chop channel names do not have to be literally X or Y. Any names will work provided. You can use an operator called chop, pop, to DAT to inspect an operator's internal data. In our case, this makes it possible to confirm numerically that the chop channels have been translated into pop coordinates. Begin by adding a constant chop to define amplitude and frequency. Then add a logic chop so that the LFO chop, reset, outputs 1 only when its signal equals 1. For each LFO chop named X1 and Y1, reference the common frequency value and each channel's respective amplitude value from the constant chop, amp_frequency. Here we use the script expression me.digits, which returns the trailing numeric portion of an operator's name as an integer. This expression is very useful and is one I use frequently in practice. Use the logic chop as the reset reference for the LFO chop. Merge the X and Y channels you created, and convert them to pop as before. Add a feedback pop and a merge pop to generate trajectories. Drag and drop the merge pop onto the feedback POP. As before, reference the logic chop for the start parameter of the feedback POP. To deepen your understanding, convert each pop to DAT and inspect the data frame by frame. Doing so will clarify why the trajectories are produced. Offset half of the amplitude in the negative direction so that the center aligns with the origin. Duplicate the Y, merge chop, and null chop you created. Replace the Y inputs connected to the merge chop one at a time. Duplicate the chop to pop and drag and drop null chops. Because the frequency is identical across all copies, we multiply it by me.digits so that the resulting value increases progressively according to each operator's trailing number. Next, prepare for rendering. To render in TouchDesigner, you need to prepare a geometry comp, a camera comp, and a render top, and then assign a material of your choice. In this case, we'll add a constant MAT and set it as the material. Change the camera S projection to orthographic, and set the ortho width to 40. Set the background color alpha to 1. Add a copy pop and a circle pop to replace the points with circles. Duplicate the copy pop and the circle pop, copy and paste them. Connect the merge pop that contains the lead points to input one of the copy pop. Add a merge pop and merge the trajectories and the lead points. This will allow the lead points to be rendered. Add a lookup texture pop and apply color as you prefer. To draw the line connecting the origin and the lead point, add a line POP. Use the values from the null chop as the coordinates for position 1 in the line pop. As before, offset half of the amplitude in the negative direction. Copy and paste the line POP. When you do this, you will see that it simply draws an additional straight line connecting the first point to the origin. We want each copied line pop to reference a corresponding null so that copying and pasting yields separate lines automatically. For this we again use me.digits. In this case, since we need to reference the null operator that corresponds to our own trailing digits, we use str to build that reference dynamically. Repeat the same procedure for the Y side. Then duplicate and merge as before.